At the turn of the 20th century, European armies were wrestling with a hard truth: traditional field artillery was outdated. The older guns recoiled violently when fired. After each shot, crews needed to reposition and re-aim. That cost time that could save lives or lose ground. For the nation of France, determined to modernize and learn from past defeats, the need for better artillery became urgent. It was in this climate that the conception of what would become the French 75 began. Design work started in the early 1890s. The result was a radical and elegant solution to the problem of recoil. Instead of letting the whole carriage jump back after firing, the barrel and breech would recoil on rollers while the carriage remained fixed. A hydro-pneumatic mechanism, using oil and compressed air, absorbed the recoil and automatically returned the barrel to firing position. The carriage did not move, so the crew did not need to re-aim after each shot. When the gun fired, the recoil was confined within the mechanism, not the battlefield. This was a revolutionary advancement. Introduced officially in 1898, the French 75, often simply called the 75 or Soixante-Quinze, quickly became the backbone of French field artillery. Its lightweight, relatively compact size, and advanced mechanics allowed it to be towed by horses, and in later years, by motor vehicles, making it far more mobile than heavy siege guns. But the real revolution lay in its rate of fire. Traditional field guns of the time might manage 2 or 3 rounds per minute. The 75 could deliver 15 to 20 rounds per minute of sustained fire, and with a highly trained crew, even up to 30 rounds per minute. Unbelievable difference in firepower intensity. When the First World War erupted in 1914, France possessed around 4,000 of these 75mm guns. Organized into field artillery regiments, entire formations were built around these pieces. At the outset of hostilities, the war largely remained fluid and mobile. Armies moved, commanders maneuvered, and open field engagements still occurred. In this context, the 75 excelled. Its quick deployment, rapid rate of fire, and accuracy made it ideally suited to provide covering fire, suppress enemy infantry, support advances, and respond quickly to shifting front lines. The improvements over older guns were not just technical but tactical. The hydro-pneumatic recoil system meant fewer delays between shots. The use of fixed ammunition, shell and propellant case combined, allowed much faster loading and firing. The breech mechanism was a quick-action screw breech, with a simplified yet efficient system, reducing the time and complexity involved in loading. These innovations turned the 75 into what many historians call the first modern field gun. Yet as 1914 turned into 1915 and 1916, the nature of warfare on the Western Front shifted dramatically. The initial expectation in war of motion gave way to entrenched positions, static lines, fortified trenches, and vast networks of defensive works. In this new reality, the 75's light shells, roughly 6 kilograms to 7 kilograms, were not well suited to obliterating concrete defenses or deeply buried structures. The flat trajectory and low-angle fire that worked well in open fields limited its effectiveness in trench warfare, where high-angle plunging fire was often needed to strike behind parapets and into enemy trenches. At the outbreak of the war, many 75mm batteries used shrapnel shells. These shells were designed to burst in the air above enemy infantry, sending metal shards raining down, devastating open-field infantry formations. This suited the style of warfare expected in 1897, when armies often fought in open order across fields and clearings. However, with the onset of trench warfare, shrapnel lost much of its effectiveness. Enemy troops were no longer massed in open fields, but hidden in trenches and covered behind fortifications or terrain. Consequently, high-explosive shells, often filled with melanite or other explosives, became primary. These shells detonated on impact, making them more effective against fortifications, bunkers, barbed wire, and enemy artillery positions. The 75's high rate of fire made it possible to deliver heavy barrages, suppress enemy defenses, cut wires, and prepare infantry assaults. As the war dragged on, ammunition demand skyrocketed. The use of 75mm shells became almost obsessive. At certain points, the demand for shells outstripped supply. Production ramped up massively, shell output rose from some thousands per month to tens of thousands per day. Civilian industry was mobilized, women entered munitions factories, and new manufacturing processes were adopted to increase output. But this massive production often came at the cost of quality control. Reports arose of shell defects, premature detonations, and barrel bursts. At one point, the French command ordered that 75mm guns be used only as a last resort. The crisis forced reforms. Quality controls were improved by late 1915, but the increased rate of production and lowered standards left a mark on reliability for the remainder of the war. Perhaps the darkest chapter in the 75's wartime history was its transformation into a delivery system for chemical warfare. From about 1916 onward, specially designed toxic gas shells, chlorine, phosgene, mustard, and other chemical agents were introduced, and the 75 became, in many cases, the primary means of delivering these weapons onto enemy lines. Its high rate of fire, accuracy, and mobility made it frighteningly effective for this purpose. The gun that had once been celebrated for rapid fire and mobility now delivered smoke, high explosives, and poison. In addition to shrapnel, high explosive, and gas shells, by the war's end the 75 fired a variety of specialized rounds. These included smoke shells for concealment, star shells, illumination rounds for nighttime battlefield visibility, incendiary shells, and even armor-piercing, trench-clearing shells in attempts to deal with concrete bunkers, light fortifications, or enemy light armored vehicles. This breadth of ammunition types and evolving roles demonstrated the remarkable adaptability of the 75 and its well-rounded shell size, and unlike many weapons of the era, it refused to become obsolete. Instead, it evolved. The versatility of the 75 extended beyond towed field artillery. As early as 1915 to 1916, French engineers proposed mounting the 75 on armored vehicles. By 1918, the 75 was the main armament of early French tanks such as the Saint-Chamond tank, giving these machines better firepower than earlier light tanks armed with machine guns or small-caliber weapons. In addition, the 75 was adapted for use in anti-aircraft roles. Some were mounted on truck or specialized carriages to engage enemy aircraft, a role unimaginable at the time of its original design. The fixed carriage and lightweight made such adaptations viable. After the war, as militaries around the world reassessed their artillery doctrines, the influence of the French 75 was evident. Though heavier artillery became preferred for fortification busting and long-range bombardment, the 75 remained in service, not just in France, but also in many other nations which had purchased or been supplied with 75mm guns or license-manufactured versions. By the time the Second World War began, several thousand French 75 pieces were still in service, many updated with new wheels and tires to allow towing by motor vehicles rather than horses. The longevity of the 75 underlines its foundational design strengths, ease of manufacture, mobility, adaptability, and a flexible ammunition system. For decades the model set the pattern for field artillery worldwide: light caliber, rapid fire, recoil-absorbing mechanisms, and fixed ammunition, features copied or adapted by many armies. For many, the French 75 symbolized ingenuity, mobility, and modern firepower. It rewrote the book on field artillery. On the battlefields of 1914 to 1918, it delivered barrages of shrapnel, high explosive, smoke, illumination rounds, and gas shells. It supported infantry advances, suppressed enemy defenses, cut through barbed wire, illuminated night assaults, and delivered poison. It became an icon of French resistance. Yet for all its technical brilliance, the 75 also became an instrument of one of humanity's darkest innovations, chemical warfare. The fact that the same gun which once sprayed lead balls over open fields would later launch shells filled with poisoned gas is a stark reminder of how technological innovation, once unleashed, can be turned to devastating ends. The transformation from a tool of rapid fire and mobility to a carrier of toxic death reflects the brutal evolution of World War I itself. At the same time, the enormous consumption of ammunition, the wear on guns and crews, the industrial strain of shell production, the decline in quality control under pressure, all illustrate the hidden costs of such an artillery war. By 1915, the shortage of shells had become so critical that civilian factories had to be retooled, production scaled up massively, and munitions manufacturing opened to less experienced workers. This in turn led to defective shells, accidents, and barrel failures. The 75 had to endure the consequences. Yet despite those costs, despite shifting battlefield conditions, the 75 endured. Its adaptability, in ammunition, carriage, deployment, kept it relevant for decades. By the end of the First World War, thousands of 75mm guns had been produced. These guns found their way into the arsenals of many nations: the United States, Serbia, Greece, Portugal, Belgium, Poland, among others. The design influenced countless other artillery pieces worldwide, as nations scrambled to match its speed, reliability, and rate of fire. In conflicts beyond the First World War, the 75 continued to appear, in colonial wars, in interwar skirmishes. But in early stages of the Second World War, while it was no longer the apex artillery piece once heavier guns became common, its mobility and flexibility kept it in use. Many units appreciated having a proven, dependable gun familiar to crews, easy to maintain, fueled by massive production lines, and still capable of delivering effective fire against infantry, light fortifications, or soft targets. For decades after the Great War, the 75 remained a symbol of French artillery. It was displayed in museums, remembered in stories, in the memories of veterans, and in war literature. Its distinctive bark of fire, its recoiling tube returning to battery quietly, its rapid burst of shells, these became part of collective memory. At the same time, as warfare evolved, later generations looked back on the 75 with a mixture of admiration and regret. Admiration for its revolutionary design and impact on artillery doctrine. Regret, because it also represents the darker possibilities of modern war: chemical shells, mass death, destruction of trench networks, and the total war that defined the 20th century. The story of the French 75 offers a powerful narrative. It is not just a tale of metal and mechanics. It is a human story of ingenuity under pressure, of adaptation, of desperate demand and chaotic industrial mobilization, of bravery and horror, of the endless push and pull between weapons innovation and the suffering they inflict.